going down the ramp. And again, it's kind of what I just sketched in the last slide. It shows a curve. Now, if you recall, on a position versus time graph, when we had a diagonal line, I said that the slope of the line is your average velocity. Here, with a curve, it gets a little trickier because notice with a curve, it doesn't just have one single slope. Now we could come up with the average velocity. We could take the position. We could essentially draw a line between our first point and our last point. I don't know if I can draw this too terribly well, but if I connected my first point and my last point with a line and took the slope of it, that would give me the change in position divided by the change in time from the beginning of the trip to the end of the trip. And that would give me the average velocity. However, notice that that slope there is not the slope, let's say, between these 2 points, or the slope between these 2 points, or the slope between these 2 points. So it turns out the difference between our motions is that when the ball rolled across a desk, a nice constant velocity, it gave me a diagonal line on a position versus time graph, and that, because it's a line, the slope is the same anywhere along the line. And you can also think about it as, what if you had a little speedometer attached to that ball? If you asked it how fast it's going as it's rolling across the desk, it would tell you the same answer over and over and over. So the average velocity is actually the same as the instantaneous velocity anywhere along the trip because it was moving at a nice constant pace. However, in the case of the ball rolling down the hill, you can calculate an average velocity by knowing the change in position and dividing by the change in time over the entire trip. But if you ask the ball along the way, if it has a little speedometer, how fast are you going, you're not going to get the same answer over and over again. The instantaneous velocity is constantly changing because the ball is constantly speeding up as it rolls down the hill. And notice that your slopes from this position versus time graph, that's a curve, the slopes of these individual lines change. Remember, the slope of a line does give you velocity on a position versus time graph. The difference being with a curve has a constantly changing slope. A diagonal line has just a constant slope. It doesn't change.